Okay, so now we have rigging. So rigging is how we attach a load and lift it. So how do we choose the right rig? We have to think about the safety factor, the braking strength, blocking, slings, and there's many styles of slings. So what is our safety factor? How much weight is it going to take to break our rig? And then we want blocking to stay clean, and this is going to make sense later. But basically, this is a wire rope sling, and it's good because it can't be crushed. So we zoom in on on the um on the sling. We've got a rope, and the rope has a what we call a thimble, which is the inside, and the rope has a mechanical swage. So the sling, our load is being held right here in the sling, and so this portion starts to wear out, and the crown starts to wear out, and the thimble starts to dig into the rope. So here's an example where we've got a beam, and we're lifting the beam with our sling. So the sling is tied to whatever or up top, and we've wrapped our sling around the beam, and then we've tied it here with a hook. So we added this hook. So you can see this part of the sling starts to wear out because this is rubbing right here as the load moves. So this starts to wear out and this starts to wear out. So the other thing is these edges of the beam are sharp, so a smart guy put these like, and every load is different, but in this case he's put some material like a quarter round or whatever this is, like a, maybe this is a PVC pipe or something to protect the sling from sharp edges, because again, you're pulling this up, this is rubbing against the metal and it could cut the rope. Here's another example of a box beam, and he's lifting up the box beam, so he's put some wood blocks around the beam, and this is keeping the rope from touching the edges. So when we use a sling, we don't want to have sudden movements. We want to like reduce stress. So we stop and start to lift really slowly, and we don't want to bend around the sharp edges, which can kink the sling. And the hook should be above the center of gravity. So we have a safety factor. Now, how do we figure out the sling? Well, safety factor is, so a safety factor of 5 to 1 for hoisting. That means if we're lifting 1,000 pounds, then we want to get a sling that works up to 5,000 pounds. 10 to 1 for humans, 20 to 1 in an elevator. And then so we can calculate our workload in tons, and then D is the diameter of the rope. So if you want to know what rope you need, you just it's actually the safe workload in tons is equal to the diameter squared times 8 for a safety factor of 5. So if my rope is 1 inch, so 1 inch squared times 8, that tells me that I can lift 8 tons with a 1 inch rope, if that makes sense. So, or 4 tons of people. Now you can get this, if you have the load, you can divide by 8 and take the square root, and that gives you D, which is the rope size you need. So if you know your load, you can reverse this formula to find out what kind of rope you need. Now, if you don't have a rope, you also got these fiber slings, which are synthetic, and there's 6 of them. So there's a triangle, and there's different end fittings for different types of loads. And we use synthetic slings because we can be really tight. You know, you can't bend a metal rope at 90 degrees, whereas you can really bend a synthetic sling around an object really tight, and they're elastic, so they absorb more shock, and um, they don't scratch the surfaces. Now they've got chemical coatings, so they don't wear out as fast as you think they do. And one thing is interesting, so the outside's yellow and the inside is actually red. So there's layers of fabric in a sling. And if you wear out the yellow, you see the red. And if you see the red, then you've worn out the sling and you gotta throw it out. So you wanna check your sling and see what it's rated for. And then the third type of sling is a chain sling. A chain will have an ID code to tell us the type of metal that's in it, and it's tagged telling us the load type at different angles and the length and the size of the steel. And if you can't see the code, then don't use it. So we've got 3 different types of slings here: single, double, triple, and quadruple. And the working load limit is a maximum load that can be applied to our chain. So that's how much. So the working load, so look at here. So we've got a safety factor of 4 to 1. So that means what we've done is if our chain is a 1/4 inch, then it can lift up to 3,500 pounds. If it's 7/8 of an inch, it can lift up to 34,200 pounds. Now, what they've done is they've tested, say, if this is 3,500 pounds, that's the limit. They've actually, what they did was they took the chain, 1/4 inch chain, and they added more and more weight until it broke. And so this chain that's a 1/4 inch didn't break until 14,000 pounds were added to it. So that's its ultimate limit. And then if we use a safety factor of 4 to 1, that means that we divide by 4 the breaking capacity, and we end up with 3,500. So you don't go more than 3,500 pounds. So don't exceed the working load limit, even though technically it will still work. You don't want to get close to that. Now, when you look at your chain, or sorry, when you look at the wire rope, you want to inspect the rope because you start to see in the socket that the wires start to break. And then if you bend the chain or the rope, you'll see some frays. And what you can do is if you look at the cross section, and once you've worn out 1/3 or more of the rope, then you must replace the rope. And I'm not saying 1/3 of the whole rope. I'm saying if you wear out 1/3 or more of the outer surface, then you must replace the rope. And the same with the chain. So you have to inspect the chain regularly, and you must clean it and measure its length and keep track. Because believe it or not, because metal stretches when you pull on it. Now you gotta be like Hulk Hogan or like a superhero, but a very heavy load starts to cause the chain to stretch, and that's why over time it can wear out. So we want to inspect every link in the chain, and if it has stretched, we throw it out. Or if any single link has worn out more than 10%, or if any of the links have bent or twisted even under a magnifying glass. And the reason is because we don't know, a chain is only as strong as its weakest link, literally. So any one of these links could break, and you'd have to like zoom in, but there can be microscopic failures that break catastrophically when the next time the load is applied. Like you don't know when this thing is gonna fail, so better be safe than sorry. So when you buy a chain, when you measure, let's say 10 links or 20 links. So if 20 links are 10 feet long, then later you come back and you measure 20 links, and if they're 11 feet long, then you know that the chain has stretched. You also look for like cracks, twists, um, wear, deformation, if there's nicks or twisted or stretched links or bent links. Now, so that covers um, chains and stuff. So we're gonna end here. If you have any questions, please post a comment.